All right, welcome to Unit 6, Inference for Categorical Data on Proportions. This video is topic 6.6, concluding a test for a population proportion. So this has been kind of a long process, but we're finally on step 4 of the 4-step process for a one-sample z-test for a proportion. All right, guys, we've done step 1. We've identified the parameter of interest. We've named the test. We've written the null and alternative hypotheses. Step 2 is all about believing that the null hypothesis was true and building that sampling distribution. And step 3 was saying, all right, let's get our evidence. Let's find our sample proportion. Let's get a z-score. Where does it fall? Let's find that probability of it occurring, or more extreme, we call that the p-value. Now it's time to make a conclusion. Guys, essentially it comes down to a very simple idea. Is the sample proportion that was found significant or not? We make this decision based on the p-value, since the p-value tells us how likely or unlikely the sample proportion is, assuming the null is true, of course. The only other detail we have to discuss is where do we draw the line as to what's significant or not. I've been kind of saying 1% a lot in class in all these videos, right? But be honest, it could be a couple different things. Well, first and foremost, we call this the significance level, or the alpha level. Yeah, we actually mentioned this back when we were talking about confidence intervals. This is alpha. Alpha is the proportion, or the percentage of samples that you deem to be significant. This is like, for example, if you're going to be 98% confident, that means the top 1%, the bottom 1% are very significant. That means 2% of samples are significant. So that's your significance level. That's called the alpha level. It's right. It's where you're drawing the line as to what's considered significant or not, right? So you got to make sure you understand that we have usually been using 1%, but honestly, it's very common for people to use 1%, 5%, or even 2.5%. I mean, I'm going to write this, but not be very happy with it. Some people will even use 10% as significant. I don't know, I think that's kind of high, but some people will, right? I will say the most common levels are 1 or 5%. Those are the very, very common levels, right? And again, these are our alpha levels. What we're saying here is that 1% of samples are significant. Are we one of them? Or, hey, 5% of samples are significant, right? Significant means special, weird, very unusual. Are we one of those samples? All right? So all we have to do here is get our p-value and figure it out, right? So, it basically comes down to this. So here's that line. Here's that 0.01, right? Are we below the line? Do we have a p-value that is very significant, showing that our sample is very, very unlikely, special, unusual? Or are we above that 0.01? Is our p-value bigger than 0.01, which means that our sample is, totally normal, not significant at all. All right, so the two conclusions that you're going to make, and again, the most important thing I want you to understand is the conclusion has to be just really, really nicely worded. The first possible conclusion is rejecting the null, right? If our p-value is less than the significance level, that means that our sample is statistically significant, which tells us that the fact that it did occur can only mean that the assumed null hypothesis is wrong, right? This means that we do have evidence to reject the null hypothesis and claim that there is sufficient statistical evidence to support the alternative hypothesis. And again, this is why I like drawing a picture. Gosh, that's a really bad picture. Okay, but again, that's the normal distribution, right? And right smack dab in the center is, the null, the proportion we assume to be true. If our p-value, our probability of our sample is really, really, really low, then that's significant. That means that our sample was very unusual, very unlikely to occur, which can only mean one thing, that the alternative is correct, that we are right. So again, if the p-value is less than or equal to your alpha, your significance level, again, which is typically 0.01 or 0.05, this means that we're going to reject the null. That's the proper language that we use. Reject the null hypothesis. We're basically saying, you're wrong. We're going to go with the alternative, right? Again, think about that criminal court case I was comparing this to in previous videos. If that person's saying, I didn't do it, I'm not guilty, I'm not guilty, but all this evidence shows that you did do it, and I'm saying, what's the probability all this evidence is pointing towards you and you still be innocent? Gosh, the probability of all that is very, very unlikely. then what I'm going to do is I'm going to reject your claim that you're not guilty, and I'm going to go ahead and send you to jail. I think you're guilty. So that's what rejecting the null hypothesis means. Now, the flip side of this is that you could fail to reject the null hypothesis. This happens when our p-value is greater than the significance level. This means that our sample proportion is not significant. Well, that means it's pretty normal, which tells us that our sample was not unlikely to occur at all. It might have been a little different than the assumed null hypothesis, but it wasn't so strange to mean that the null hypothesis is wrong. So again, let me draw a picture of this. I know I'm bad at drawing pictures, but you get the idea, is that right smack dab in the middle is the p that we assume to be true with our null. If our sample proportion was just a little lower or just a little higher, well, that doesn't mean anything. That doesn't mean that the p's wrong. Now, listen, it doesn't mean that the proportion in the middle is right. I just don't have the evidence. I do not have the sufficient statistical evidence to prove that the null is wrong. Listen, we're not confirming that the null hypothesis is correct. We simply do not have enough evidence to say otherwise. We do this when the p-value is larger than our alpha value. This is when we fail to reject the null. Think about it. If you have a sample that is just a little bit lower, then the p-value, the probability that you are even lower, is going to be really, really big. And what that means is that your sample is very likely, which means it's not special. So we fail to reject the null. I can't emphasize enough that we are never looking to confirm the null. And that's what's true in criminal law too, right? Nobody in that courtroom is trying to prove that this accused murderer is innocent, right? The prosecutor is trying to prove the alternative, that he's not guilty, or I'm sorry, that he is guilty. The prosecutor is trying to prove that he's guilty. The defense lawyer is simply defending him. He's not trying to prove innocence. He's just trying to say, okay, if the prosecutor brings up some evidence, I have to try to show that that evidence is wrong and that my guy is still innocent. But he's not going in there trying to say, all right, I'm here to prove you're innocent. No, he's just defending. So no criminal court case ends with, you're innocent, go ahead free into the world. No, we just say, there wasn't enough evidence. We thought we had enough. We tried, but we just don't have enough evidence to say that you are the murderer. We're not saying you're innocent. We're just going to say we don't have enough evidence. And again, that's exactly what's happening here. If you want me to use a real world example, I will. O.J. Simpson, right? He got left out, right? He was let out. He didn't go to jail for murder. But a lot of people do believe, and I'm not trying to give my opinion here, but a lot of people do believe he was guilty, right? But nobody ever said, all right, O.J., go free. You're innocent. The jury simply came back and said, we listened to a lot of evidence. We just don't feel there's enough evidence to send you to jail. We're not saying you're innocent. We just don't have enough evidence to say you're guilty. So that's what happens when we fail to reject the null. We're not confirming the null. We're just not rejecting it. Okay? All right. So please take your time with this conclusion. It's super important that you get the wording perfect, very clear, very neat, and in context. Okay? A significance test will lead to either rejecting the null or failing to reject the null. Use that language. Never, ever conclude or prove that the null is true. That's not what we're doing here, right? Lack of evidence for the alternative is not the same as evidence for the null, right? Just because I couldn't show, or the prosecutors, just because they couldn't show that OJ was the murderer, doesn't mean that he's innocent, right? They just didn't have enough evidence to send him to jail, okay? So, a good conclusion, all good conclusions begin with explicitly comparing the p-value to the significance level, right? Then you have to word, are you going to reject, or you're going to fail to reject in context, right? So you always start off with saying, my p-value is less than the significance or greater, and here's my conclusion because of that. Hopefully that's all very clear. We're going to try to do as many examples as we can to make sure that's clear to you. But you got to make sure you understand. You got to be very specific with that language. Okay. So one more word on p-values before we look at some examples here. Right. The lower a p-value is, the more convincing the statistical evidence is for the alternative hypothesis. Or likewise, the higher the p-value is, the more reason we have to fail to reject the null. If there is really absolutely no evidence at all, then you know what? It probably would have never even made it to court in the first place, right? But we hate p-values that are really towing that line with the level of significance, because that's when the decisions are hard to make. We're like, oh man, it's a low sample, but is it really that low? And that's the idea, right? But listen, regardless, follow the protocol. You're going to either be given a significance level or you could pick one, either 1 or 5%. If you are below that alpha level, reject. Otherwise, fail to reject. All right, again, this is a lot like a criminal court case. But instead, we have a proportion, right? We got a P, we got a proportion. He's screaming, I'm right, I'm right, I'm right. And our job is to support the alternative that he's wrong. If we get good, solid evidence, even though that we thought that he was correct, then that's what we could do, right? So if we get that good evidence, we could put that proportion away for life and say that it's wrong. Otherwise, we just don't have enough evidence. So we don't claim that he's right. We just simply say that there's not enough evidence to say otherwise. All right, so let's just dive right back into the same example we've been looking at a lot recently. 35% of adults have experienced depression in their lifetime. David, the mayor of a large town in Vermont, believes that his town is more happy, hence less depressed. So he gets 350 people, 91 say that they felt depressed. That's 26%. Does he have significant evidence that his town is less depressed? All right, let's run through step one. The null, truth is 35%. We're going to believe it. Alternative, no, it's less than 35%. That's what David believes. Step two, build that sampling distribution on the assumption that the null is true, on the assumption that 35% is true. Then look at our sample. Remember, David's sample came back at 0.26, 26%. So we find the z-score very low, negative 3.5294. We find the probability, this is the p-value, the probability of a sample being less than 0.26, right? That's even lower, even more extreme, which is equivalent to finding a z-score less than negative 3.5294. Use normal CDF on our calculator to get this probability, and it's very, very unlikely. This is definitely a significant sample. This sample of 0.26 should not have occurred, but it did. So now as for my nice conclusion. All right, since the p-value of 0.000208 is less than 0.01, I'm going to go and use my famous significance level of 0.01. That's my alpha level. Okay, so remember, you need to do this. You have to explicitly compare your p-value to your alpha level. Since it's less than 0.01, I'm going to reject the null. Now, what does rejecting the null mean? In context, our sample does provide very strong statistically significant evidence that for his town, the proportion of adults that have experienced stress in their lives is less than 35%. David is right. 35% can be put to jail. It's wrong. In David's town, it is definitely statistically proven that less people are depressed. All right, guys, that's it. 4 very easy steps. Sense a little sarcasm there? Yeah. All right, I get it, right? There's 4 steps. A lot of running, a lot of work. Usually takes a full page. But I'm going to be honest, guys. If this all clicks, it's pretty easy. It's not that hard. And you know what? If you like answering research questions, if you truly like kind of like learning about the world around you, I might even venture to say this is kind of fun. All right, let's try one more example. Same example we've also been working with in the previous videos. Just want to make sure all the details are there. News report says that 62% of all students feel anxiety. Sally wonders if that's true for her school, or maybe her school's something different. So she gets a sample of 220 random kids from her school district. 66% feel daily anxiety. Does this give her evidence that her school is different than the rest of the country? All right, this is going to be a 1 sample z-test for the proportion of students that feel daily anxiety. She's going to go ahead with the null and believe that what she read is true. 62% is the true P. The alternative is she wonders, is her school different? Just simply not 62%. Step 2, build that sampling distribution on the assumption that 62% is true. Pretty easy to do there. Nothing hard there. Pause the video if you need to see that anymore. All right, her sample came back at 66%. All right, now we got to find the z-score for 66%, which we got 1.2232, just a little bit higher. The p-value is the probability of a sample being more extreme, in this case, higher than 66%. Find the z-score higher than 1.2232. Use normal CF to get that. Now, don't forget to double it. I already mentioned this in the last video. This is a two-sided test, so you got to make sure you double that p-value. Go back and watch the previous video to explain that. But her p-value ends up being a total of 0.2212. Well, I'm not going to lie, that's not that weird at all. That's pretty likely. What we're saying is that this sample of 66% is a very likely sample on the assumption that 62% is true. Look at the picture. 66% is really just right here, right? It's barely that high at all. It's not, in fact, totally normal. So now my conclusion. Since the p-value of 0.2212 is greater than 0.05, yeah, just for fun, I decided to switch it up and use an alpha level of 0.05. To be honest, it wouldn't matter if I used an alpha level of 0.01 or 0.05. 0.22 is definitely greater than. Most problems will give you the alpha level to use, or you could just use whatever you want. But anyway, since my p-value is so likely, I'm going to fail to reject the null. What does that mean? There is no statistically significant evidence to claim that the proportion of students at Sally's school that feel daily anxiety is any different than 62%. Am I saying that 62% is correct? No, I'm just saying I don't have enough evidence that her school is different than 62%. At the end of the day, it could be a little different, but there is certainly no evidence to support that at all. And guys, that's it. That's how you make a conclusion. It's really just a couple sentences, but it's got to be written very clearly, very concisely. You got to make sure you explicitly compare your p-value to your alpha, and then tell me you're going to reject, you can fail to reject, and then go ahead and give me a nice blurb in context. That's it for this video, guys. I hope you found this whole process to be not too bad. Now we just got to kind of put it all together, work on some problems.